Welcome to another video. Today in our mini-series about different hardware debuggers and their features is the FT2232 mini module from FTDI. This can be found for around $30 online from a variety of retailers, and it's the same chip as we've seen previously on our CJ-MCU module and the ESP-PROG modules. This is compatible with the standard 2.54mm pin spacing, so you can use your existing jumper leads to connect it to most boards easily. However, there are a number of other connections which are needed on the debugger itself. These configure the power for the debugger as shown on the connection diagrams, and more can be seen in the datasheet. We've built a small breakout board for ours to make it simpler to wire this up to different targets, as well as implement the SWD hack, which is explained shortly. Like all hardware debuggers, there are limitations on the number of concurrent breakpoints which can be set, and for this probe, the limit is a maximum of 6 breaks and 4 watch points, we believe, but this can also be limited by the target hardware and debugger configurations. It can be used to debug a variety of different boards, as it supports JTAG, SWD and other protocols for debugging and programming, therefore supporting a variety of common Arduino platforms. These include STM, ESP-32, as well as a number of Mbed-based platforms such as the Raspberry Pi Pico and the Nano 33 BLE. Connection diagrams are available for a variety of boards on our website with links below, and a few of them are shown here. If you are powering your board through its own USB connection, don't connect the power line between the probe and the board, as this will also supply power to the board from the probe. However, if power from the probe alone is not enough for your board, then disconnect the VCC line between the probe and the board, and then power the board through its own USB or power connection as normal. Ensure you leave the ground line connected between the boards in all scenarios. Also note on this diagram that we have a 470 ohm resistor which has been added between the TDI and TDO lines of the debugger. This allows the SWD to work reliably on this debugger, and this is the same for the CJ-MCU and ESP-PROG debuggers, which we've already seen. To make things a little easier on all of our probes, we've simply put this resistor on a breakout board so we can add it to our setup easily as needed on any debugger. As this is the dual port chip, this probe also has a second interface available, which you can run your serial lines through, meaning all connections from your board can go through the probe itself. Now we've got our board wired up, we can get this working in Visual Studio using Visual Micro. First, to allow the debugging software to locate and control the probe, we will need to change the default driver installed in Windows for this device. Connect the probe to your machine through its USB connection and install the Zadig tool with a link below. Once the Zadig tool is loaded, simply click List All Devices and select Interface 0 of your device. Then select the Win USB driver for installation. Click Install and wait for the process to finish. This can take a few minutes. Note, we don't need to change the driver for interface 1, as this is the serial pass-through port and the driver that it has is fine. Remember, if you do move which USB port of your PC the probe is connected to, you may need to reinstall the driver with Zadig. Now that's done, we can close the Zadig tool. So now we can load our sketch in Visual Micro and select our board as normal. To set up the debugging, simply select Debug Hardware and then the FT2232 mini module from the drop-down lists. If you want to use this as a programmer as well, if it's available instead of the USB port, select the option from the vMicro Upload Hardware Programmer option, and this will allow the upload to happen through the JTAG or SWD interface that you're using instead of the serial port on the board. If you have connected the serial wiring through the probe as well, you can select this COM port in Visual Micro for the serial monitor so you can see the data from that port. See the video in the top right, which is also shown in the end, to learn more about using and navigating the hardware debugger generally, and also check out our unique serial debugger for an alternative approach which requires no probe at all. you can either perform your build and upload as normal, and if you run the debug attached process, you enter the code where it's currently executing on the chip, useful when you want to jump into a project once it's gone wrong. Alternatively, you can run debug, start debugging, which will perform the build and upload, and then attach the debugger at the start of the program all in one click. If your setup does not work as expected at this point, please see our hardware debugging troubleshooting video in the top right, as this guides you through resolving common issues. Once the debugging session has started, you can inspect variables, move and reconfigure break and trace points, as well as other inspection of source code and disassembly. Let us know in the comments if this was useful and if there are any other details or features we need to add to this series that you need. Don't forget to check out the other videos on our channel and give us a like and subscribe to stay up to date with more videos coming in the future.